Hello everyone. In this video, we will be learning about line symmetry and rotational symmetry. Symmetry in mathematics, symmetry is defined as that one shape is exactly like the other shape when it is moved, rotated, or flipped. Line of symmetry, it is nothing but the imaginary line, L, or axis along which you fold a figure to obtain the symmetrical half. Here you can see the line of symmetry in the case of the alphabet A and line of symmetry in the case of Taj Mahal. One half it is exactly matching or it is the mirror image of the another half. Let us recollect few terms that you have already learned in the previous part of this chapter. Rotational symmetry. If a figure is rotated around a center point and it still appears exactly as it did before the rotation, it is said to have rotational symmetry, and the point around which the rotation occurs is called as the center of rotation, and the angle of turning during rotation is the angle of rotation. The number of positions in which a figure can be rotated and still appears exactly as it did before the rotation is called the order of symmetry. Now let us consider an equilateral triangle. An equilateral triangle has three lines of symmetry and it has three rotational symmetry as well. And the angle of rotation is 120 degree here. In the case of an isosceles triangle, the line of symmetry is 1 and it has no rotational symmetry. A parallelogram is a quadrilateral which has no line of symmetry but a rotational symmetry of the order 2, and the angle of rotation is 180 degree here. A kite is a quadrilateral which has only one line of symmetry and no rotational symmetry of order more than 1. Let us consider a square. We know that a square has 4 lines of symmetry and rotational symmetry of order 4. Center of rotation is at the point of intersection of the diagonals. In this tabulation, we can have the information about the center of rotation, order of rotation, and angle of rotation of each geometric shape. We have already seen about square. In the case of rectangle, the center of rotation is the intersection point of diagonals, and order of rotation is 2 and angle of rotation is 180 degree. In the case of a rhombus, center of rotation is at the intersection point of diagonals and order of rotation is 2 and angle of rotation is 180 degree. Equilateral triangle, we have already seen the center of rotation is at the intersection point of medians. Order of rotation is 3 and angle of rotation is 120 degree. In the case of a regular hexagon, center of rotation is at the intersection points of diagonals. Order of rotation is 6 and angle of rotation is 60 degree. In the case of a circle, center of rotation is at the center of the circle. Order of rotation is infinite and angle of rotation is any angle. In the case of a semicircle, the center of rotation is at the center of the semicircle and order of rotation is 1 and angle of rotation is 360 degree.